Assalamualaikum warahmatullahi wabarakatuh, and a very good day to all the students. So we continue again our topic, which is in chapter 6 for the DRM1413. And this is the new subtopic, which is drilling. So let's look at what are the content for today's lecture, which is drilling. So basically things that we are going to look at on drilling topic is a little bit on introduction for drilling. What are the cutting conditions and how drilling being conducted? I mean, its operations on how to conduct drilling. And of course, last but not least, we are going to look at on the machines for drilling. So as for the introduction, let's look at this video.
Drills are the most commonly used tools for creating holes. Short spotting drills are used to create shallow, conical holes, preventing longer drills from wandering off center. Frequent retracting, known as peck drilling, helps clear chips. Screw machine drills are much shorter and can drill straight, accurate holes without spotting. Programming a CNC machine to drill holes is simplified with the use of canned cycles. The table and spindle initially traverse to the starting position of the first hole. The G81 command, followed by various parameters, initiates the canned cycle. G81 is a modal command, meaning it stays active until another command cancels it. Drilling additional holes only requires specifying new coordinates. Drilling into an angled surface requires spot facing using a center cutting end mill. After spot facing, a standard drill can be used. Chucking reamers are used to enlarge pre-drilled holes to very precise diameters. Slow speeds as well as coolant or lubricant should be used. Power tapping is a fast way to tap holes on a conventional machine equipped with a quill and a 3-phase instant reversing motor. Synchronized rigid tapping on a CNC machine is accomplished using the G84 canned cycle. Helical boring with an end mill is an economical way of creating larger holes. Deeper holes can be made using a boring head. The adjustable twin cutter unit shown here is used to enlarge pre-drilled holes. A finish boring head holds a single adjustable cutting edge for the highest precision and the smoothest finish.
That's it. That is the general content for drilling. So you can see from the processes now, this is actually highlighting various operations for drilling methods. But in general, when we are talking about drilling, it is actually referring to a process of creating a hole on a workpiece. So this is workpiece, and this is the drilling bit, they call it. So drilling is actually a process of creating a hole on a workpiece using a machine which is known as drill press, and its cutting tool is known as or called as a drill bit. So in drilling, we can either drill until it reach the end of other thickness of our workpiece, and we can also do drilling by creating a hole for certain depth of thickness only, which means that we do not create a true hole for our workpiece. And of course, for drilling bit itself, we can control its speed by using this formula, which is N equals to V over pi D with the units of revolution per minute. Other than that, we also can control the machining time with this formula. So basically, this one is a formula for true hole for this condition, and this one is for blind hole. So this one. Other than that, we can also calculate the material removal rate in drilling using this formula. So, you have seen in the video just now, there are various operations in drilling. For example, reaming. Reaming is a process of enlarging an existing hole, and normally it is used to provide a better tolerance, improve surface finish, or improve surface finish. Yeah. Other than that, second is tapping. Well, tapping is a process whereby we have a hole, then we want to create a screw thread in it. So that is tapping. Other than that, counter boring. Counter boring is a process of creating a hole in a hole with a larger diameter, as you can see in this illustration, in this figure over here. So that is counter boring. Counter sinking, the process is the same as counter boring, but then the hole that been created is cone shape. So we're gonna need other types of head screw head for creating such hole. So let's look at a video for counter boring, how it is being conducted.
Counterboring is often needed to recess cap screws in parts. A counterbore is machined after drilling has taken place and creates a larger diameter along the same axis as the hole that was drilled previously. The diameter and depth of the counterbore is determined based on the blueprint, or by the diameter and height of the head of the cap screw that will sit in place. Before counterboring, be sure that the pilot on the counterbore will fit into the drilled hole. The cutting edges of the counterbore should be set to the surface of the part. In this example, the counterbore will machine a recessed hole for this cap screw. Counterbore should run at approximately 1/3 of drill speed, used to drill the hole, and carefully plunged until the needed depth is achieved. Be sure to use cutting oil and monitor the chips for good coloring.
So that is counter boring. And let's look at what is counter sinking.
Okay, this is a countersinking tool. Two different things that we can do with the countersinking tool. First one is chamfering. Chamfering is just going in and breaking that edge around the top. If we go deeper with the tool, the operation is called countersinking. We'll use this for a flathead screw.
Okay, so that is it. And other than previous various operations, it's not the one that we've seen just now. There are other types of operations as well, like centering, which is normally is used to creating a hole before start drilling. So that is centering. And then spot facing. Spot facing is more or less the process is more or less the same as milling. It used to provide a flat machine surface on the workpiece. So now let's look at an example for spot facing on how to conduct spot.
Look at spot facing. Spot facing is just cleaning up the top of a hole to let a fastener sit on it. We're going to start with a center drill, and then we'll use a twist drill, and then we'll use our counterboring tool to actually make the spot face. So just a little spot drill with the center drill, follow that with the twist drill, do some peg drilling, make a hole. Spot facing is used a lot of times on casting when the surface is uneven to help the fastener to sit down level on the top of surface.
Okay, that is spot facing. So now let's move on to a drilling press or a machine that is used for drilling. Number one is upright drill press. So as you can see from this figure here, upright drill stands on the floor, normally used on the floor, consists of a table to hold the workpiece. A drilling head is powered by a powered spindle for the drill bit, and base and column for support. Column and base. Meanwhile, there's also another types of machine which is called bench drill. It is same design, more or less the same design, but slightly smaller, and mounted on a table or bench. It does not stand on the floor because it stays on a bench. That's why they call it as a bench drill. Other than that, this is also drilling a machine, which known as a radial drill press. Radial drill is a large drill press used to cut holes in large work pieces. It has radial arm where the drill head is clamped and can be moved over here. And it has gang drill, whereby it consists of a series of 2 to 6 upright drills connected together in an inline arrangement. It is used for a series of drilling which are performed in sequence. And last but not least is this type of machine, which is a very popular or very famous, and one that we have in our lab also, this type of machine, which known as CNC drilling machine. So I think that will be all for today for subtopic under drilling, and we shall meet again in next lecture, next class. So thank you very much for your attention, and hopefully you understand for today's lecture. So thank you very much, and see you again. Bye.